All right, so this is number 3 off of the net torque worksheet. So we have a 3 kilogram mass and a 4 kilogram mass. So I'm going to call this guy M1. This guy will be M2. Shh. Now look, a very common question about this pulley. So the most common question I've heard is, what's the mass of the pulley? Well, I don't know. You could actually figure it out because you're given the rotational inertia, right? So if this is a solid disk, the equation for the rotational inertia for a solid disk is 1/2 mr squared. So you could solve for what the mass is because we know what the radius is. All right. Now look, in this problem, the pulley is not massless. The problems that we did first semester, you didn't have to worry about the pulley at all. What we said first semester is the tension on each side was the same. But if this pulley has mass to it, which means it has rotational inertia, to get this spinning, it requires a net torque. So which way? So when this system starts, which way is this pulley going to start rotating? It's going to rotate clockwise, right? Which means which torque is going to be larger? The torque from T2 or the torque from T1? The torque from T2 is going to be larger in order to get that pulley spinning, to get it rotating, accelerating. Okay, so this problem requires 3 free body diagrams. So I'm going to make some room here. We're finding the acceleration of each mass, and it's going to be the same, right? The 2 masses are connected together. So the acceleration of mass 1 and the acceleration of mass 2, it's going to be the same acceleration. Okay, so let's make some room, and we'll do a free body diagram first. Let's make this even bigger here. All right, so I'm just going to do the free body diagram right on here. So T1, so take this off like that. I'm going to erase, it's frictionless, we take that off. Okay, let's get rid of this, just kind of clean this up. So M2 is 4, M1 is 3. All right, so here are the forces. So this is T1. This, here, move this out of the way. So that's T1. This is T2. That's T2. M2 was 4 kilograms, so we're going to have M2G down, and then for M1 we're going to have M1G and then a normal force. Okay, and they tell us the surface is frictionless. No friction on this surface, so we don't have to worry about that. And then M1, this is equal to 3 kilograms. Okay. Now, next thing we're going to do, sign conventions. Look, you want the direction of the acceleration to be positive. Which way is M1 going to accelerate? M1 accelerates to the right, so we're going to say to the right is plus, to the left is minus, like that. And then that sign convention is going to go around the pulley. So over here for M2, we're going to say down is plus, up is minus. Okay? And I would even, you want that acceleration to even agree with the rotation of the pulley. So for the rotation of the pulley, look, which way are we going to say is plus? Clockwise plus, counterclockwise minus. That's going to be the signed convention for the pulley. So the next thing to do is we're going to sum forces and sum torques. Okay, so that's the setup of the problem. Okay. So now, for M1, we're going to sum the forces in the x direction. How many forces are in the x direction for M1 right here? Just one. T1, that's it. That's the only force in the x direction. What is the sum of the forces equal to? MA, but make sure you say M1A. And that's a linear acceleration. Okay, now let's go to M2, hanging over here. So now make sure down is positive. You want the direction of the acceleration positive. So we're going to sum forces for M2. So we're going to get M2G minus T2 equals M2A. And those A's are the same. Those accelerations are the same. Now, guys, by the way, at this point, look at how many unknowns do we have? 3. We got T1 as a question mark. We got T2 as a question mark. And we have acceleration as a question mark. Uh-oh. If you have 3 unknowns, how many equations must you have? 3. So how are we going to get a third equation? We're going to focus on the pulley and sum the torques. Okay? Now let's blow the pulley up. Let's blow this up so we can really see it. Ready? So here's the pulley. Ready? Boom. Okay. A little bigger. So summing the torques for that pulley. So now we're looking at the pulley. Summing the torques. And we're going to say clockwise is positive, counterclockwise is negative. All right, what's the torque for T2 going to be? Well, what's the equation for torque? The equation for torque is what? Force times lever arm. And they have to be perpendicular. So let's start with T2 because we're saying that's positive. What's the perpendicular distance? What's the perpendicular distance from the axis to T2? It's the radius. And the radius is 0.3. Everybody see that? So the torque for T2, you're going to go T2 times R. That's the torque for T2. Minus the torque for T1. Now what's the perpendicular distance to T1? It's the radius. That's going to be T1 times R. Now, what does the sum of the torques equal? Is it equal to MA? No. It's equal to the rotational equivalent to MA, which is I alpha. So the mass becomes I, which is rotational inertia. The A becomes alpha, which is angular acceleration. Okay, so now we got 3 equations, but look, we got to substitute in for this alpha here. What's the equation that we need at this point? Linear acceleration. If you focus on a point on the perimeter of the pulley, the linear acceleration is equal to the angular acceleration times the radius. Just like we did, look, for tangential velocity. For a linear velocity, a point on the wheel, it's equal to angular velocity times radius. That make sense? Okay, so let's plug this in. So this is going to be, so alpha equals A over R. So let's just plug that in for alpha. So this is going to be IA over R. Okay? All right, guys. The remainder of this problem is what? Algebra, which I'm not going to, I don't want to do 7 minutes. Look at here's my algebra on this page right here. What you got to do, let me just kind of get you started. It is a little bit of algebra. Would this be a multiple choice question? No. This would be more free response, right? This would not be a multiple choice question. Yo.
How do we know what I?
Oh, they give us I. I's right here. Bam. I is 0.5. Yo.
Response on,
I'm thinking for next week's quiz, free response. Mm-hmm.
I said we still one.
Okay. All right, guys, look, before you pack up. T1, plug it in right there. Okay, what you do is you take this equation, solve it for T2. T2 is going to equal M2G minus M2A. Take this, plug it in there. You have everything except A. The worksheet uses gravity as 10. For this worksheet, McGehee used gravity as 10. When you do the algebra, you're going to get A equal to 3.18 meter per second squared, which rounds off to 3.2. Then, how do you get the tensions? Take the A, plug it back in there. T2 comes out as 27 newtons. Plug this in there. T1 comes out as 9.6 newtons.